This is exam number 3, video 1. I will start by going through each likely chemical and showing how I got the information that I'll be using in the chart at the end, which will show how I would differentiate each likely chemical. So for sucrose, I'll start by giving the formula as use this for some of the solubility and electrolyte stuff, which is C12H22O11. The solubility is that it is soluble because the bond between the hydrogen and the oxygen is soluble because hydrogen is in group 1A. It is a non-electrolyte because it's covalent, so it doesn't ionize, and it is not a conductor. For sodium carbonate, the formula is Na2CO3. For solubility, it is soluble because one of the exceptions for CO3 2-, because usually it's insoluble, one of the exceptions is group 1A, which sodium is a part of. For if it's an electrolyte, it is a strong electrolyte because it is ionic and it is soluble, and it is not a conductor. The formula for naphthalene is C10H8. For solubility, it is insoluble because it is, even though hydrogen is in group 1A, it's nonpolar because the difference between the electronegativities for carbon and hydrogen is 0.4. For if it is an electrolyte, it is a non-electrolyte, mostly because it's insoluble, and it is not a conductor. For magnesium, there isn't really a formula, it's just Mg because it's an element, it's elemental magnesium. Solubility, it is insoluble. This one's a little complicated because the magnesium will react with water to form MgOH2 and H2 gas. And MgOH2 is insoluble because Mg is not one of the exceptions to OH- being insoluble. Is it an electrolyte? It is a non-electrolyte because no ions are present after the reaction is done. And it is a conductor, though, because before you put it in the water, it is a metal, so it's a conductor. And silver chloride. The formula is AgCl. For solubility, it is insoluble because even though Cl- is often soluble, one of the exceptions is the Ag+ ion. Is it an electrolyte? It is a weak electrolyte because even though it's insoluble, it is ionic, so it ionizes a little bit, but not enough to be considered a strong electrolyte. And it is not a conductor. So that's how I got the information for this chart. I'm going to use the highlighter tool so that I can show you how all this information will lead up to us being able to differentiate each likely chemical and how you could tell them apart. So after the formula, we have the first row after the formula is solubility. So the ones that are blue are soluble, and the ones that are green are insoluble. This basically halves our list already, even though it's uneven. But that means that if it's soluble, it's either sucrose or sodium carbonate, and if it's insoluble, it's one of the other three. In the next row, we have, is it electrolyte? So in the two soluble ones, the blue highlighter is the non-electrolyte, and the red is the strong. This means that if it is soluble and a non-electrolyte, then it is sucrose, but if it's soluble and a strong electrolyte, then it's sodium carbonate. Now, for the insoluble ones. So the green highlighter is non-electrolytes, and the yellow highlighter is weak electrolyte. So if it is insoluble and a non-electrolyte, it is either naphthalene or magnesium, but if it's insoluble and a weak electrolyte, then it is silver chloride. Since we have differentiated between each one except for naphthalene and magnesium, they will each get their own color for highlighting. So, as we can see, naphthalene is not a conductor, so it'll have green, and magnesium is a conductor, so it will have gray. So this, if you look at the bottom, each one has a different color, meaning that we have separated these with each row to the point where we could tell which one is which, depending on our findings.